My name's Ian. I'm here today to talk to you about this little thing behind me, the Green Park wind turbine. So the turbine from the tower itself, that's the thing, as it goes up towards the great big egg-shaped thing on top. The tower itself is 85 metres in height. The egg-shaped thing on top, obviously the three blades come away from that. Those blades are the things that physically catch the wind, and those blades measure 35 metres in length. That means at the turbine's highest height, that's as the blades go over the top of the hub, it's an absolute maximum of 120 metres tall. In terms of weight, the whole construction weighs close to 300 tonnes in weight, which is very similar in weight to a Boeing 747 aeroplane. The hub itself, the egg-shaped thing on top, the nacelle for all the engineers out there, weighs about 20 tonnes just on its own. Now this is what we call a floating hub on this particular turbine, meaning that the whole thing can gradually move all the way around, and it will go all the way around at hub height, 360 degrees, in under about 3 minutes. Now this wind turbine is designed to work in wind speeds of on or around the 4.5 miles per hour mark, and will operate right the way through the wind speed spectrum up to its maximum wind speed of about 70 miles an hour. So as you can see, the hub or the nacelle, that contains all of the major component parts on this particular turbine. And this is what we call a direct drive turbine. In effect, all of the major mechanics that we need are contained within that hub. And effectively what we have up there is two metallic plates, one made of tightly woven bound copper wire, the other magnetic in form. And if you imagine the plates, the magnetic plate revolves with the wind turbine blades, and as it does so, it revolves around the copper wire. When that happens, effectively through a process called Faraday's law, on site right here, we make electricity. Now, as you can appreciate, what happens with the electricity is it comes down through the tower, through an inversion process, we won't talk much about that, and then effectively we put it into the grid or into the national grid on site. So in November of last year, 2020, the wind turbine effectively became 15 years old. So it celebrated its 15th birthday. And we tell a lot of people that they're absolutely gobsmacked, surprised by the length that it's been up. And I was fortunate enough to see it go up. 15 years ago that event happened, and it does surprise me. So I want you to have a quick think for me, if that's okay, about all the things involved in our normal day-to-day lives, right from when you get up in the morning, right to way till when you go to bed at night, that are affected by electricity. And the reason I'm asking for you to do that is the minute that you start to think about all the things that electricity is involved, electricity in your life, you'll start to realise just how much electricity plays a part in our life, and that's very, very key for us. I'll tell you the simple reason being. Let's have a quick think about all the things in your life. So the lighting, the heating, a lot of the heating involved in homes nowadays is electric, a lot of the lighting, anything that uses power, anything with a plug and a socket. But further and wider from that, if I was to ask you how you got up this morning, you got up on a bed made in a factory using electricity. You were on a mattress made in a factory using electricity. The duvet which covered you, made in a factory using electricity. The cereal that you had this morning, I don't know, maybe you didn't have cereal, or the toast. If it was the toast, it was a toaster. If it was cereal, manufactured in a factory using electricity. So we don't think about electricity as part and parcel of our normal daily lives, but it affects everything that we do. And that's really important for us because in the UK, as a general rule of thumb, most of the electricity for most of the things that we do comes still, unfortunately, from burning fossil fuels. And when we burn that coal or that oil or that gas, unfortunately, that creates pollution, a generic term, and very, very importantly, obviously, contained within that pollution is a lot of key gases. And those gases go out into our Earth's atmosphere, and unfortunately for us, are causing something called climate change. So if you've ever seen traditional sort of conical type chimneys dotted around the British landscape, one of which not far from here, north from here, Didcot, very synonymous in the local area, and normally you see these huge plumes of smoke coming out, steam coming out the top of that. That's exactly the sort of thing we're suggesting here. So those are associated to something called coal-fired power stations, where we make a massive amount of electricity, but unfortunately in doing so, we also create pollution and climate change. So in this instance, just a bit of diagrammatic, I'm going to show you, obviously, this is planet Earth, and planet Earth is surrounded by this invisible layer of gases, nothing more than a gaseous layer. Lots of gases in there, oxygen, carbon dioxide, nitrogen, methane, all manner of gases, but this gaseous layer built up around our Earth called our atmosphere. Now in this instance, if through traditional energy generation, coal, oil and gas, when we burn those, particularly the key gas that we need to talk about is carbon dioxide, when that goes out into our Earth's atmosphere, it's like adding a gaseous layer or a denser layer around the Earth's atmosphere. And in this instance, what I'm going to do to show you that is represented through this hot water bottle. So it's like adding another layer around the Earth. Now obviously in this instance, this hot water bottle represents heat. So this gaseous layer or this pollution layer effectively prevents the heat from the sun escaping, and it keeps the heat contained within our Earth's atmosphere for a longer period. Now, those of people of my generation understand this because of the last 10 years on record, 8 of those have been the warmest. And I appreciate we're in the middle of winter right now and it does feel cold, but as a general rule of thumb, things are gradually getting warmer. They are heating up. A lot of scientific evidence to suggest this. Over 90% of the scientific community believe in global climate change. In context of our globe, in terms of the snow and the ice in the South Pole particularly, there's a huge amount of snow and ice contained there, and obviously if we were to heat that up, effectively what happens is that melts down and then goes into our sea level, and that causes the sea levels to rise and lots of other consequences as a result of global climate change. We're starting to see migration, we're starting to see crop failure, we're starting to see a whole manner of consequences for humankind. Now in this context, the Green Park wind turbine, I've already told you, it makes nothing more than electricity from natural wind, admittedly smaller quantities than a power station, but if you take a look, you can see quite clearly that it's not producing any pollution, it's not creating smoke of any description, it's still producing electricity, so it's quite obvious as to what I'm getting at here. The wind turbine makes electricity, but it doesn't create any byproducts, it doesn't create that smoke, it doesn't create pollution, and it helps us in combating climate change.